Control tomorrow's costs through today's designs. Contents. 1. Cost discipline, why now? 2. Olympus, from cost targets to target costing. 3. Olympus moves to close the gaps. 4. Komatsu's suppliers bring costs down. 5. Smoothing out the target costing process. 6. Target costing and the organization. 7. Making it work. Target costing lets customers, not the product, set the price. Over the past 15 years, company after company has learned that quality must be designed into products before they are manufactured, that it is expensive, if not misguided, to attempt to inspect in quality after the product has left the production line. Today the most competitive companies are applying the same logic to determining the price of new products. Before a company launches a product, or family of products, senior managers determine its ideal selling price, establish the feasibility of meeting that price, and then controlled costs to ensure that the price is met. They are using a management process known as target costing. Target costing drives a product development strategy that focuses the design team on the ultimate customer and on the real opportunity in the market. Leading Japanese electronics and vehicle manufacturers have used target costing to their advantage, and companies are now introducing it in the United States, Germany, and elsewhere. Its rigorous cost management technique helps prevent senior managers from launching low-margin products that do not generate appropriate returns to the company, but its greater value lies in its ability to bring the challenge of the marketplace back through the chain of production to product designers. Target costing ensures that development teams will bring profitable products to market not only with the right level of quality and functionality but also with appropriate prices for the targeted customer segments. It is a discipline that harmonizes the labor of disparate participants in the development effort, from designers and manufacturing engineers to market researchers and suppliers. The logic of target costing is simple. By looking at tomorrow's marketplace, the organization maps customer segments and targets the most attractive ones. It determines what level of quality and functionality will succeed within each segment, given a predetermined target price, and volume and launch date. The organization then designs the sourcing, production, and delivery processes that will enable it to achieve its desired profits at this target. In effect, the company reasons backward from customers' needs and willingness to pay instead of following the flawed but common practice of cost-plus pricing. Target costing ensures that success with the customers will yield economic success for the company. Cost discipline, why now? The logic of target costing is so simple and compelling that one may wonder why it has only recently begun to receive attention. After all, at any time in the past, senior managers could have gained much from becoming involved in the process of pricing and costing a product before it was designed. Their lack of involvement gave engineers and enthusiasts, who were unlikely to see the whole picture, undue influence over the company's competitive position. When senior managers try to drive costs out of their operations ex post facto by cutting staff, eliminating frills, outsourcing, or re-engineering downstream processes, they often discover that as much as 70% to 80% of a product's costs were effectively immutable after it left the designer's hands. As product and process technologies have become more integrated, a product's cost has become even more strongly tied to its design. Nevertheless, although a preemptive and disciplined approach to costs has always been reasonable, it has not always been urgent, and companies do not usually undertake difficult tasks if the tasks are avoidable. These days, however, price and cost targeting are no longer avoidable, largely because of the erosion of important first-mover advantages in the new global economy. In the past, many leading companies, especially those that led by technical differentiation, found that they could take a cost-plus approach to releasing new products because they anticipated profiting from serial generations of products. They believed that being first to market was most important. That in preparing to be first, design teams needed to focus only on selecting and executing well the appropriate bundle of product attributes. And that ultimately, over several iterations of the product, the marketplace would allow the company to earn a reasonable return on total capital employed. By that logic, when the product was first released, it might carry a comparatively high price considered affordable by only a small number of lead users, such as businesses hoping to turn a new technology to their advantage or comparatively wealthy, adventurous technophiles. Lead users would pay a premium for the first-generation product and help create excitement for its new features. They would even help establish the brand. The revenues from lead users would rarely cover the cost of developing the product. Hewlett-Packard Company, for example, did not expect the first releases of its laser printers to recover R&D costs. But first-mover companies have assumed that they would have time to scale up to mass production and introduce serially cheaper versions of products for increasingly broader segments of customers. The mass market would be the source of most profits, as indeed it was for consumer products such as the 35mm camera and the fax, and for components such as ABS brakes and digital TV controls. Today that strategic assumption would be disastrous for all but the most advanced products, those with highly proprietary technologies. Global markets no longer allow a company time to introduce a product and then scale up. Now imitators usually lean enterprises can bring me-too products to market so rapidly that first-mover companies have no time to inculcate brand loyalty, let alone recover their development costs. Lean competitors, with faster reflexes and old mass production companies, work on shorter product development and life cycles, and they manufacture almost anywhere: Korea, Mexico, Israel. Their growing number and increasing ubiquity of lean competitors means that copycat versions of most new products will be available within months, not years. So if market leaders can't recover costs as they used to, they have no choice but to manage costs from the design phase forward and to launch products at prices that will attract broad segments of customers and forestall imitation. How long they can hold on to their market, then, will often depend on how quickly they can offer greater functionality without raising price. For companies to gain and hold market leadership today, they have to design the cost out of their products when they set initial levels of quality and functionality, and they have to calibrate product performance to an identified price niche. In other words, senior managers need to approach new product development controlling for tomorrow's costs, not just today's. And tomorrow comes more quickly than it used to. Olympus, from cost targets to target costing. In Japan, competition among lean companies has become so intense that aggressive cost management is critical to survival in some sectors. It is thus no accident that leading organizations such as Olympus Optical Company and Komatsu developed and adapted target costing earlier on. Olympus was a leader in single-lens reflex, SLR, cameras, which had no technological competitor for a generation. But by 1987, compact cameras built around a miniaturized electronic shutter had absorbed so many advanced electronic controls features such as automatic exposure and zoom that consumers began to view them as a serious alternative to the SLR. Olympus had introduced a compact of its own as early as 1978, but not as a main focus of its product portfolio. In the mid-1980s, Olympus began losing money, and by 1987 its losses were substantial. Senior managers saw severe problems. Cameras incorporating the new electronic technologies suffered from poor quality and there were no individual product hits. The managers concluded that the planning and development of product families needed improvement. Externally, Olympus suffered from the sudden shift from SLR cameras to competitors' compact cameras and from a steady appreciation of the yen. The company reacted first with an effort to regain lost share by introducing a number of new products, for example, SLRs with advanced electronics and compacts with an advanced zoom. A second initiative was aimed at improving quality, which historically had been high at Olympus and which continued to be crucial to its ability to lower the total costs associated with its products. But most important to Olympus was the third initiative, reconciling production costs to a volatile market. Managers believed that the company's ability to manufacture cameras at a cost that would meet the increasingly stringent expectations of its customers would be central to the success of any new product. Moreover, the company's product development process would have to meet challenging price and profit targets within 18 months of their being set, before the competitive environment could shift again. This was not the first time that Olympus managers had set cost targets for new products, but earlier targets had been more or less hypothetical. Senior managers had created no imperative to meet them, and these targets did not prevent products from being launched. Essentially, designers did their best on functionality, manufacturing engineers pursued efficiency, and marketing sold what was produced. All that changed in 1987. First, Olympus tried to establish a clearer picture of what features future customers would value in new product families. It produced a corporate plan that identified the future mix of businesses by major product line, the desired levels of profitability, and the contribution of each product to the cultivation of the brand. And it performed the technology review to learn how current and future technologies would affect the camera business. The technology review included an audit of Olympus's proprietary technologies that could be turned to the company's advantage. Its market mapping included an analysis of the general business environment to determine how macroeconomic factors, such as changing exchange rates and the further segmentation of income groups, were likely to affect consumer demand. Finally, the marketing research included a survey of information collected from such sources as Olympus questionnaires, group interviews, interviews at fashion centers, and interviews with photographers, as well as a competitive analysis that examined areas such as competitors' capabilities, likely price points, and filed patents. With a clearer sense of what the camera market would bear and what Olympus's profitability goals required, the company identified the price points at which new compact cameras would sell. The U.S. market price for basic compact camera models in 1991 was about $100. With that price as a baseline, Olympus analyzed consumer trends, competitors' performance, and forward-looking technology to establish what relationship it could anticipate between distinctive camera features, such as magnification capability or smaller size, and higher price points. From each price point, Olympus subtracted the appropriate margins for dealers and its U.S. subsidiary and also subtracted import costs, such as freight and duties, to arrive at the price that would be paid to the factory for any new model. Then, by subtracting its own margin requirement, Olympus finally arrived at a preliminary target cost for each new product. Now what it needed was a disciplined process for developing products that could be made at those costs. The responsibility for ensuring that the company could produce cameras with the features customers wanted and at costs within the targeted limits fell to a product development management team at Tatsuno, the site of Olympus's primary manufacturing operations. Only when designers and manufacturing engineers could demonstrate that estimated production costs did not exceed target costs would a camera be submitted for release to production. Olympus moves to close the gaps. This process may sound straightforward, but it was not. Only about 20% of proposed new models cleared Olympus's hurdle on the first pass. However, the 80% that missed were not abandoned. As at many companies, it was not uncommon at Olympus for product managers to design nice-to-have, but not need to have features into their products. The product development management team's job was to ask whether the value those features added really outweighed their costs. Correspondingly, they would ask whether an enhanced product could justifiably be moved to the next higher price point so that its estimated costs would generate acceptable returns. Soon enough, those reviews ended. If target costs could not be met or price points could not be changed, the team returned the product to research and development for redesign. In the context of this review, Olympus managers used a lifecycle analysis to reckon the cost of important new technologies incorporated in new product designs. That is, they assessed the value of a technology's contribution to features that could be expected to serve a variety of models over the lifecycle of a whole product family. They did not attribute the technology's costs only to the first models introduced. Further, they separated the whole cost of a new technology into its two components, the costs of research and development and the costs of production. The Olympus product development team determined that in allocating research and development costs, product designers should consider how long a camera family is likely to be on the market, on the order of 3 years, or how long a specific feature is likely to find application in other camera families. As for production costs, Olympus managers learned that even after a product family comes to market, the costs associated with new technology often decline quickly and dramatically with the adoption of manufacturing programs that actually increase product quality, for instance, by reducing the number of parts in a sub-assembly, eliminating labor-intensive mechanical adjustments, or moving from metal or glass to plastic. The number of parts in the shutter unit of one entire class of compact cameras, for example, fell from 105 to 56, a reduction that led to a 58% decrease in production costs for this widely used component. By 1990, Olympus managers had discovered that the company could generally reduce its production costs by approximately 35% across the production lifetime of its new products. The product development management team incorporated this figure into its target costing of future products. On the whole, lifecycle analysis helped many potentially profitable products clear the hurdle. The practice may sound vaguely like the old strategy of distributing costs over successive generations of buyers, from lead users to mass markets, but it is different. There is no thought here of introducing the product family at high prices that then fall as volume increases. Cost, not price, is expected to fall. Cost reductions of this magnitude don't happen without strenuous effort. For existing products and processes, Olympus monitored and managed fixed costs, purchase parts costs, routine production costs, the costs of defective production, capacity utilization targets, and overhead expenses. And Olympus used its falling production costs in a number of ways. At times, it raised margins. At other times, it selectively dropped price points. On the whole, however, the company used cost savings to improve its products over time. The one thing it did not do was take a short-term profit, which, in the unforgiving environment of lean competition, would have been the most dangerous option. A company that just cashes in its market advantage invites imitation and invests nothing in sustaining its technical differentiation. Komatsu's suppliers bring costs down. As the Olympus experience illustrates, target costing issues a clear-cut but daunting challenge to product designers. They cannot call a design a success unless they meet the functionality needs of the customer, the price demands of the distribution channel, the manufacturability requirements of the plant, and the financial projections of the corporation. Komatsu's experience illustrates another way to use target costing, in this case to pressure suppliers to drive their costs down. Komatsu's earth-moving products contain many more components than do Olympus's cameras, and the company relies more heavily on outside suppliers for complete subsystems, hydraulic devices, electrical subassemblies, and the like. In 1993, for example, Komatsu manufactured roughly 30% of the content in its heavy equipment products, designed and subcontracted 50%, and purchased the remaining 20% from outside suppliers. Moreover, the number of choices Komatsu must make regarding components makes it difficult to control development costs. Which features will the company offer on which models? Which teams need additional support? Where should the company be refining designs and where should it be rethinking entire design approaches? Komatsu must involve suppliers in product design early in order to make informed decisions in those and other important matters. Throughout the entire product development process, Komatsu poses a challenge to its suppliers to maintain the performance specifications of components and deliver at prices consistent with Komatsu's overall target costs. Komatsu's target costing program provides the parameters that guide its negotiations with suppliers and sub-assembly makers to ensure a profitable product launch. By linking performance needs and the company's margin requirements back to each major sub-assembly, Komatsu's design team can track the performance of the whole vehicle and keep an eye on the integrated goal, a product launched at a price the end user will find attractive, not simply a sub-assembly that satisfies product designers. To develop system and component targets for its suppliers, Komatsu relies on data on historical performance and cost that it has recorded in function and cost tables. Function tables, containing information about the physical characteristics of each component, help designers determine the company's best performing components. cost tables, containing information about the cost of components, help designers identify the low-cost components. By, in effect, overlaying one table on the other, Komatsu engineers identify the target cost of the best component for a given project. This target cost becomes the supplier's target price. In developing the target cost of an excavator's cooling system, for instance, Komatsu's engineers determined that the most important performance factor was the surface area of the system's radiator. They consulted function tables to calculate the minimum radiator surface area required. They consulted cost tables to calculate the most cost-effective design. Then they calculated the target cost of their radiator to reflect both minimums, least surface area and minimum cost per unit of area. In demanding that the radiator in the excavator's cooling system be both the most efficient at cooling and the most cost-effective, Komatsu forced its suppliers to push the frontiers of their own technology to achieve more efficient designs. It is important to remember that subsystem target costs must fit within an overall target cost, which has been derived from a projected market price. But if a subsystem's cost exceeds its projected share of the product's target cost, Komatsu does not automatically reject the design or reduce the cost targets for other components. Like Olympus, Komatsu focuses not on some mechanistic algorithm but on the complex relationship between cost and price and the effects of both on value. Komatsu asks whether particular functions need to be continued. It provides engineering support to suppliers that cannot meet targets. It seeks unexploited opportunities to reduce costs even further among components that have already met their targets. Komatsu managers do not measure success one department at a time. They know that the marketplace does not reward an outstanding component, only an outstanding integrated design. Smoothing out the target costing process. Clearly, target costing involves more than listing dollar targets and projected margins. It is a highly structured product development discipline, adapted to such specific elements of a company's strategic positioning as industry pricing dynamics, product complexity and life cycle analyses, and supplier relations. It requires a company to make a series of decisions that include defining the product that customers want, ascertaining the economics required for profitability, allocating targets to components, and identifying the gap between target costs and initial projections of manufacturing costs. See the diagram. The target costing process. The target costing process. On the other hand, as the experiences of Olympus and Komatsu suggest, target costing is not an exact science. It depends on credible data and on people who have the courage to make difficult judgments. Target costing is an iterative process that cannot be decoupled from the ordinary push and pull of the design process. The targets evolve as teams seek to balance functionality, price, volumes, capital investment, and costs. Also, because target costing is integrative, responsibility for achieving targets must be shared across functions. Finally, if they are to use target costing, companies must treat their suppliers as partners both during the design process and when they are setting cost targets. Our description may make target costing sound like a smooth ride, but troublesome roadblocks can show up at different stages. Defining the product, targeting the marketplace. The choices that drive the entire target costing process are the customers. What prices will customers accept? What functionality will they insist on? What will competitors offer them? Because the ultimate goal of target costing is to maximize a product's total profitability, not minimize its cost, companies must do their best to understand how their customers' preferences and their competitors' products will evolve over time. That requires a thorough understanding of the customer's behavior in each market segment. When the Japanese targeted the luxury car market, for example, they already knew one critical feature of luxury cars: they had to be quiet. For years, manufacturers had tried to lower sound levels in luxury cars and found the task inherently difficult. Sound level not only traded off against acceleration, high-revving engines tended to be loud, but was also an integrative challenge, because sound came from many other design components, including the drivetrain, tires, and door seals. Japanese researchers discovered, however, that frequency was as important to customers as decibel level. That is, the nature of the sound was as important as its loudness. This discovery pointed to a different design challenge. Instead of minimizing sound, designers could try to tune the car in a pleasing fashion, an approach with enormous ramifications for the way companies set their target costs. The relationship between volume and frequency points to the challenge facing anyone engaged in product positioning. Any approach that asks customers, "Do you like this offering better than that one?" and stops there will not yield much insight. Marketers need an approach that will reveal deeper patterns of customer preference. Fortunately, researchers can use sophisticated surveying techniques such as conjoint analysis to reveal how potential customers cluster around multiple product features and functionalities. These preferences must then be expressed as innovative design options, what we might think of as quality and functionality targets. It is at this point that companies might use such interfunctional design techniques as the house of quality, which maps the relationship between customers' desired features and specific engineering characteristics. It is not enough to focus on the customer. Competitors are a parallel concern. Most companies define competitors as companies that make things similar to what we make, which is the producer's view of competition. In target costing, the Japanese companies we have studied tend to define competitors from the customer's perspective. I am about to make a purchase, so what are my options? Olympus, for example, benchmarked itself not only against camera manufacturers but also against the makers of CD players and Walkman-type products. The company understood that it was competing for discretionary dollars against makers of all kinds of consumer gadgets, not just against camera makers. Computing overall target costs. Companies derive overall targets in a number of different ways, but the purpose is always the same: to think rigorously about the company's future profitability. In fact, some Japanese companies classify target costing as a profit management tool rather than as a cost control tool. In any case, the task is to compute the costs that must not be exceeded if acceptable margins from specific products at specific price points are to be guaranteed. For most companies, this order of logic represents a radical shift in thinking. Traditionally, companies perform the financial analysis associated with product development only after much of the development work has been done, and then only to determine whether to continue investment. In contrast, a financial analysis done early in the design process can accomplish much more. In target costing, it can tell design teams and general managers a great deal about what is required to make the product a success. The nature of the analysis may be the same, but shifts in timing and focus make a huge difference. One U.S. vehicle maker we have worked with performed a financial analysis to estimate a likely return on investment for a redesigned product launched under a single set of hypothetical conditions. The purpose of the analysis was to make senior managers more comfortable with their decision to go ahead. So although the analysis aided the approval process, it provided little guidance to the design team. It displayed no sensitivity to the fact that conditions such as launch date, cost, and volume are variable and that small changes matter. Our analysis of the company's data showed that to miss cost targets would have been catastrophic. A 5% error would have eliminated any return on the company's $200 million investment. Allocating target costs, identifying the gap. Once a target cost has been calculated for a new product, the design team has to divide it up among the product's various functions. How much can the team spend on one function as against all the others? The team must first calculate the gap between the target cost and what it estimates it would cost to build the product with today's processes, suppliers, productivity levels, and materials. The difference is a good approximation of the excess cost that must be wrung out of the new product. It usually makes no sense to apply cost reduction requirements uniformly across all the components and subsystems of the contemplated product. Rather, the design team can consult customer value surveys, historical trends, and other data to guide it in determining how much cost it can remove from each component or subassembly. The team will allocate more costs to critical features, allowing for increased engine cost in a car that is intended to have a peppier ride, for example. but every extra dollar it allocates to improving one product feature must come from another function's allocation, because the target cost remains fixed. Isuzu Motors' target costing system, like others, aims to keep prices constant while adding as much functionality as possible to each new generation of vehicles. The system therefore attaches great importance to determining what features and level of performance the customer will want most, and it uses those preferences as the basis for allocating costs to major functions and group components. Market researchers ask customers to estimate how much they would pay for a given function. Then they develop ratios of preference by asking customers to estimate the relative importance of each function on a 100-point scale. Isuzu uses this information to spread a product's target cost among the major specified function improvements. If the target cost for a component is too low to allow a sufficiently attractive or safe version to be produced, the component's target cost is increased and the target cost of other components is decreased. Thus, Isuzu continually uses its best sense of customer value to drive its design team's cost allocation decisions. Obeying the cardinal rule. All design team members, whatever their function specialty, must regard the overall final cost target as an unalterable commitment. Target commitments outrank design commitments. The idea is that aggressive targets focus the efforts of the design team on creative solutions and press value engineering to its limits. In other words, to say that target costing is an iterative process is not to say that target costs, once set, are then subject to ongoing debate. They are not. Targets must fall under the protection of what we call the cardinal rule. If you cannot meet the targets, you cannot launch the product. That being the case, the process of product definition and target generation continues, but not in the factory. Some companies have a layered set of targets. The first pass is the simplest, and failure here leads to a more sophisticated life cycle analysis. But this approach must not become a game with ever lower hurdles, each test becoming less rigorous than the one before. As one manager puts it, in the past, if a specific project failed the test for funding, we just kept changing the assumptions for the project or revising the test until the project passed. Target costing will not tolerate that. The cardinal rule applies to the product as a whole. When targets are assigned to individual sub-assembly teams, some teams will beat their targets, some will meet them, and some will fall short. But success is not determined component by component. It is achieved or not by the final product. When components turn out to be more expensive than anticipated, the cost must be offset somewhere else in the design. This requirement demands a degree of cooperation and team spirit that will necessitate change for many organizations. Target costing and the organization. Any system that cuts across organizational boundaries and communicates so many vital economic and market objectives is bound to have a profound impact on how the organization does business. One of the main benefits of target costing is that it forces companies to delineate their product development goals very precisely and in a single vernacular. In many companies, clarity of communication may be sacrificed to a general commitment to decentralization. At one large U.S. industrial company we have worked with, for example, nearly every functional department was using a unit of analysis that it had developed to answer a question of importance to itself only, and that varied subtly from every other functional department's unit of analysis. Competitors' specifications were collected by product, existing costs were computed by part, customers' needs were defined in terms of product attribute, manufacturing constraints were determined by installation point, and the capabilities of the supplier were measured by module. All those measures were related, but none addressed overall cost targets. There was no overall context within which to work. As a result, a product designer assigned to a particular subsystem could not get a clear answer to the question, how much do customers value this subsystem? Or what does this subsystem cost? Target costing requires that such problems be addressed directly. It forces companies to be specific about what customers want and what prices they're prepared to pay. Finally, target costing creates opportunities to demonstrate a commitment to customers. If targets cannot be met, the company cannot simply raise the price and launch the product. Such discipline may be painful to the people who work on a project, but it sends an important message to the organization as a whole, that customers come first and that if the company doesn't create value for them, a competitor will. Targeting costs in process and service industries. Target costing has made its mark in industries in which products require a good deal of production assembly, cars, cameras, and bulldozers. For example, however, the discipline target costing offers has uses outside the assembly environment. In processing companies, where the characteristics of the process time, temperature, and pressure determine the performance of the product, the focus of target costing shifts from the product to the process. A steel company would tend to focus on the costs associated with routings and processing time. A paper mill, on those associated with speed and breakage. The key issues: understanding market needs, ensuring satisfactory financial performance at a given price, not exceeding the target cost remain. Similarly, target costing can be applied to services, for which the focus is the service delivery system. As in process-intensive manufacturing, process is inextricable from product. Think of the issues that are important to the delivery of healthcare and fast food functions. Where services and process-intensive manufacturing diverge is in their flexibility. It is enormously expensive to convert a paper machine so that it can produce a grade or weight that was not considered in its initial design. Service delivery systems, however, are a different matter. In people-intensive, customer-responsive service delivery systems, it is not only possible to add new services, it can be hard not to. Menus are easy to extend. Room services can easily be added. Consulting firms or law firms can always enter a new area of practice. Whereas the discipline MET ensures that these extensions are profitable. Because a single service delivery system may be used to deliver a wide range of services, determining the profitability of individual services becomes an exercise in the arbitrary allocation of costs. In services, particularly those in which waiting time is critical, it is the systemic effects of individual new services, for instance, the extent to which they make the process more complex, that determine whether their revenues and value to customers offset their costs. Target costing can still facilitate a discussion of the appropriateness of a new service, but only if it focuses on the systemic impact of the service extension and questions whether this impact aligns with company strategy and profitability goals. In service industries as in other industries, target costing can help organizations resist the urge to create new market offerings simply because they have the ability, making it work. For target costing to succeed, targets must not only be valid, people must also see them as valid. They cannot be the outcome of a political process. The market analysis that yields the target prices, the financial analysis that generates the target costs, and the disaggregation procedures that allocate costs among components and subassemblies all must be trusted. The target costing process must, therefore, be highly transparent. Moreover, cost reduction objectives must be achievable most of the time. Setting T bar too high can be as damaging as having no bar at all. In fact, the Japanese set a series of what they call tiptoe objectives, that is, objectives that may be reached by standing on tiptoes, a stretch that strains the organization but does not defeat it. Also, the requirements for product functionality must be clearly and publicly articulated so that nobody tries to achieve the target cost by reducing product functionality below acceptable levels. It is no good to reduce costs by shortchanging customers. When target costing works well, quantifiable hurdles are established in a transparent process, and senior managers commit themselves to what the numbers show. Engineers receive goals that are clear and achievable, and everyone adheres to the cardinal rule. A company that meets those requirements is not guaranteed a victory in the markets it enters. It does earn the right to compete.
Thank you for your valuable time in this video. Please subscribe to our channel for more.